Alright, I'm continuing on from where I left off on the last video. If you notice, this screen in eMachine Shop looks a little different now. The reason is I started making this recording and had a nice long recording and was ready to send it to YouTube, and I played it back and realized that the microphone in my laptop had totally quit. So that's a good thing. I've replaced the microphone with a headset mic, and hopefully the sound quality is better. And I've changed the pointer to try to make it easier for people to see. But what I'd actually done was I'd copied each one of these drawings, drug it down, and pasted it here. And to make machining easier, this is going to be set up for a drill cycle where the mill will just move to each position, like center drill, tap, do whatever. If you recall in the last drawing, these circles were overlapped by this circle, which would cause a problem in your CAM software. So by dragging this down, this is the drill cycles, this is the machining cycles. I've done the same thing over here. These are what's going to be drilled, and this is what's going to be machined. Now you can still see the holes for the drills up here, but they don't have to be selected in D2NC to machine these areas. I split them off into individual files, a file DXF for this drawing, a DXF for each individual drawing. And then I want to show you another thing. Whenever you go to do a drill type cycle in D2NC, I don't know if it's a bug in it or a bug in me, but instead of it lining the drill, the way it does it, the way I use it is, it just moves the machine to each individual hole and stops and waits for you to do whatever you're going to do with, I use the quill on the mill to go ahead and drill and tap or whatever I'm going to do at that particular location. D2NC has a problem that when you tell it to just find all the circles that you're going to drill, it zeroes the machine at the center of the first hole that it's going to start on, that's at the lower left corner, instead of actually the 0, 0 of the part. So I'm going to show you a workaround with that. Both these parts, for example, D2NC, when it started it up and lined everything up, would line up probably on this dot right here, the center of it, instead of the actual 0, 0 point of this part, which is the lower left corner. I've taken these and copied each one. I'll go ahead and open the files for you and show you. I've just simply numbered them. I'll open this now. Now, if you look at the this actual part, for D2NC, its location really doesn't matter because you're going to tell it when you start that it's in the lower left section. I'm going to go ahead and go to the next one, which is the drilled part, and I'll show you the difference. We're going to go drill one. And if you notice, I've took this border off, and the center of this circle is 0, 0. That's not a drilled circle. All it is to give D2NC a 0, 0 point to start at. And it'll make a little more sense here when I actually take these two over to D2NC and start showing you how to get the CAM software, to produce the G code for what you're wanting to do. So this is the fix for that. This circle won't get drilled. It's just the starting point for the software. So go ahead and open the other two so you can see them. And the example on this one is that I didn't have to delete the border off of this one because it wasn't in the way. I just dropped this circle in the screen as a 0, 0 point. Once again, so D2NC starts from there to locate each one of these bolt holes to drill, tap, or whatever I'm going to do at that particular location. Okay, so right now I'm going to shut down eMachine Shop. I've already saved and exported all four of these files, and I'm going to go over to D2NC. Now, D2NC, when you get the software and you download it, you can have, by changing a screen setting in Mach 3, you can have your actual D2 and C button in Mach 3, which is really handy. Uh, you go ahead and start up the software. You can click here to get D2 and C. Now, when you first install D2 and C on the computer, you'll have to go into Mach 3, click on View, click on Load Screens, and then in the Mach 3, you will see Milsets, D2 and C Milset. You would select that and then open. That will add the button to your screen because a normal Mach 2 screen won't have that. So continue on. Let's go to D2 and C. And I have an example file to show you the bug for the drilling that I was talking about. So we're going to pick a CAD file, import it. I'm going to pick the example first and show you what it does. This is my first drill hole here, but in reality, 0, 0 to line up this part's down here on the lower left corner. Clicking next, I'm sorry, let me back up, restart. I get ahead of myself. Import DXF, example again, open. Sorry about it. Over here on the left-hand side, you can pick just circles as points. So it'll look for all the circles on the screen, and it'll make those just points. Then when you click next and put bottom left, if you notice where the pointer is here, it has made that 0, 0. It actually moves over a little bit, but that's a 0 point. In reality, the 0, 0 of this part is down here to the lower left. So that's the workaround I'm showing you. Now I'll reopen this as the drawing that I put the circles in the lower left corners. So we'll go here with the same drawing and open it, and you can see now that I've put an extra circle here that I'm not actually going to drill. So on this one here, we'll click on circles and points, and you can see that this first point is 0, 0, and when I click bottom left, that is the 0, 0 point of your part in XY. So to do this in D2 and C, that's the workaround. This just going to sit there 0, 0. When you hit enter, it's going to go to the next point, the next point, the next point. Now, in D2 and C, you can select the order that you want it to go to each location, which is really handy. Let's say if after you get done center drilling all these spots, and you have maybe 4 bolt holes that are one size drill bit, and then a couple holes that are a different size drill bit. Well, you can arrange that order so that you're not changing the bits back and forth, and you can tell it which one to go to, first, second, third, fourth. You'll have to play around the software to get into that, but I'm just going to go ahead and generate the G-code for this. This is a real simple one. It's easy. I'll click Path, and I will click Position and Pause over here under Other. And what that's going to do is just go to each location and stop, and then you can do whatever you're going to do at that location, and it'll generate the G-code for it. So if you look on the screen over here, let me go to the larger toolpath. Now you can see that this is the actual course that it's going to take, and each time I push cycle start, if you watch the screen, I should have zeroed it, but here we go. It stopped at 0, 0. We're not drilling a hole there, so I hit cycle start again. Move to the next location, you drill your hole. Moves to the next location, drill your hole, and continues right on around until you finish. This is really handy for locating all the holes. To me, it's a lot quicker than switching the cutters and having to mill the holes out, or trying to do it any other way. If I hit cycle start, even in this screen, it's just going to do the same thing. So we're going to go back out of here now, back into D2 and C, and take a look at, it's asking if I want to use the same file. No, I don't. Okay, so we're going to pick our first part to actually machine out. We'll do the stepper motor mount first. So that would be X-axis mounting part 1. So I'll open it. Now this time, the first screen you come into, you just want to click next. That takes everything as you see it on the screen. Notice this is a drawing that I don't have the overlapping holes. I want to tell it to align the part to the machine at the lower left corner. Okay. Then I want to go into constraints. I want to tell it that my safe Z, I'll use a 1/2 inch for safe Z. My maximum feed is 50, let's say. Maximum spindle RPM is 3,000. I'm going to be working on light metals, aluminum, so that's good enough for that. And then we can continue on to, go back to shape. And now we want to pick our offsets. So for this particular part, I'm going to just go ahead and cut the part out after I've drilled it. I, of course, would do the drill cycle first, but then I just want to cut the part out. So I'll put a pretty good sized cutter in here so that I can get the distance from here to here without pocketing. Instead of pocketing this whole thing out, let me go ahead and pocket. Let me go ahead and select this. So we'll go offset. I'll put in a tool diameter of a 1/2 inch. I'll select, this is my first machine process, and I'm going to pocket it. I'm going to tell it to step over 50% and go ahead and click offset. And what you see now is, because I selected that first, the hole in the center I can't find. So let's undo this and pick the hole in the center first. Let's do an inside at a 1/2 inch. Go ahead and offset it so it scales it down. Now I can pick this next one, click pocket, click offset, and this is just giving it tool compensation. Then I'll pick the outside, which is my final, and I'm going to do an outside and offset. So now I've set all the tool compensations for this particular part, and it redraws it. Now I can take this to path, click contour, click local shape, don't select any of them, and pick each particular section I want to do, and what I want to do first, second, and third will show up in the order. First I want to take out this pocket, so I'll move this over to work with it. I want this pocket to be, let's say, 0.1 deep. It's just a little recess for the front of the motor to sit in. Let's do it in a step of 50 thousandths. It's going to do a speed. I can ramp this. Don't ramp pockets in D2 and C, because instead of continuing to go down and down and down, if you ramp, it will go the distance of the ramp and then reverse direction and go back to 0 and then start over for every pass. It makes it take longer. You're better off just setting a plunge rate, make sure everything's good here, and adding it and closing. I want to go back to contour. I want to select, I got to click local shape, none, and I'm going to try to pick up this inside circle here. There, I got it. I'm going to move that in. My material is 1/2 inch thick, so I'm going to say 0.510. Go an extra 10 thousandths. Let's take 50 thousandths per pass. Equal steps. Same here. Now, this time we will pick the ramping. It doesn't pick the tool up in D2 and C and return to 0 on each pass. It will just continually spiral down completely through the part. So we're going to pick ramping. We'll let it calculate it. it has it at 2.82. It says its maximum is 2.83. That's good for a plunge cut. Is you want a longer ramp instead of pushing the cutter straight down. So just going to add and close that. Once again, we're going to click on Contour, Local Shape, None. Select the outside. Move the current selection. My material is a 1/2 inch thick. We're going to take 50,000 steps. We're going to ramp the outside. And this time here, when I select my ramping, it says 4. That's acceptable. Okay, I'm also going to add some tabs so this part doesn't just drop out. So under the tabs, we can just go ahead and let it do it. I can tell it how many tabs I want. 4. Now over here at the side, you can decide where you want the tabs, how you can locate them where you want on your part, different shapes. You're going to want them in different locations, different chains. Tab top, I don't need. It's got a 50 thousandths length and 25 thousandths top. Let's just make these, since I'm going totally through the material, this is figuring this from the bottom up. And so if I get a dead on 0 to the top of the material, that'll leave a 15 thousandths tab. That's good. I'm going to add and close. Okay. Once you get to this section, here is each one of your machining functions. This second one here, if you remember, I already pocketed out the material above it. So what would happen is for a 1/10 of an inch, this cutter would spiral down in just mid-air, coming from 0 to a -1.1. You can actually go in and tell it to start at the -0.1, and I'll show you. Let's edit this one. I have it selected, and we'll edit it. And it says material top. Well, there is nothing at 0 right now because we took it out with the previous pocket. So here I'll put -0.1. And so this will start actually machining at the material itself instead of in midair. I'll update it and close it. I'll select all 3 of the machining functions. Now you can switch the order of these if you'd like. You wouldn't want to do it now after you told this to start in a -0.1 position because it would definitely dig into the material. But here you can actually mark each one, move them up and down, and switch the order. We're going to go ahead and generate the G-code. Go to Toolpath. Got to regenerate in this big one. And then you can see the actual part as it's going to be machined. Now it's not showing the actual part. It's showing the corrected tool path with the compensations. But at this point right here, you're going to end up with some pauses in your program. And they're going to be because D2 and C, each individual process, each individual machining operation calls for a tool change. And if you can go in and edit these, if you come down and it's finished out the first pocket, you can see it's going to give you another tool change right here when it's going to the next one. You can click Edit back here on the Run screen. You can actually select this right here and just delete it out. So it still has the same size tool in it. It will just continue on then from the 0 point and then go ahead and take out and move to the next and the next. So if you see these in here and you don't want the pause, just go into the program Run, click on Edit G-code. It'll bring it up. And at this point you can name this instead of it being called D2NC.tap. You can rename the file. But see, here's your first tool change. You can scroll down through, and you see now for the next function, it's told it to turn the spindle off, turn the coolant off, and move to EXO. So right here, I can just delete these two. I want to leave the coolant and the spindle on. Right here it's just giving an explanation of what size tool to put in the machine. Um, we never shut the spindle off, so I can try to get this thing to select. There, we'll delete those. We'll just backspace. Take those out. Okay. Come down to the next section. We don't want to turn the spindle off again. We just want to grab all this and delete it out. The gaps don't matter. It's just going to skip through them. I can go ahead and file and click save, and it'll still be saved as d2nc.com. I mean d2nc.tap. Or I can actually change the name now, so this file doesn't get written over. I'm just going to go ahead and save it because it's not something I'm going to use again. So I'll save. I can say file, exit, and now the corrected one's in here. If I tell it to cycle start, run the speed way up, you can watch it up on the screen as it's running from position to position. And it won't ask for a tool change this time. Go to toolpath. And it's probably a little hard to see, but you can see that it's running around there pretty quick. I guess I probably should have just, while I was edited to put in a really fast feed rate, and could have done this a lot quicker for demonstration purposes. But it's just going to go pocket out the top, immediately cut out the hole, immediately cut out the outside of this part, and leave the tab. So I'm going to pause it here just a second, and if you look, and I'll zoom in so you can see it, on the side of your part here you can actually see the tabs it's left so your part does not fall out. There's 4 tabs on this part, and trying to make it so you can see them. At this point here, if we've already drilled all the holes, this piece would be done. Alright, I'm going to pause for now until I think of something else to record and upload this one.